Do you need to pass GED math? Well, if you've been out of school for a while now and maybe you're just starting to feel frustrated and confused and you feel stressed out because you feel like you have to completely relearn everything and you're just feeling completely lost and unsure of what to do to move ahead, then you're not alone and you're in the right place here. My name is Parker. I founded Test Prep Champions. I've been on YouTube for about 5 years now teaching people how to pass the GED. And in this video, I'm going to help you learn all kinds of fundamental skills. I'm going to throw a lot of things at you here. We're going to learn a lot of important things for the GED test. And my goal is to take you from feeling frustrated and lost and to get you ready to tackle some of the harder, more advanced stuff on the GED test so you can get it done and move on with your life here. And let's be honest here, you know, the GED is just a stepping stone. This really isn't about the GED. This is about you and your life, and this is really about you passing the GED so you can go on for college or a better job, whatever your goal happens to be. The GED is just the way that you have to do it. You've got to get this done to move ahead. That's what I want to help you do so we can all get on to bigger and better things, and we're going to get started right now. Okay, so on screen I have the addition tables, and let me show you how to make sense of this. So I just picked blue here just for no reason. I just was feeling blue for the numbers in the row up top here and the column going down here. So basically, let's say that you couldn't remember, just for an example here, what 5 plus 6 was. You know, you come down here to the 5 row and you go over here until you find the 6 column, and you would see, wow, the 6 and 5, they make 11. Or for example, let's just say you wanted to check what is 6 plus 8, just for an example. You know, you can find the 8s and come down here until you line it up with the 6s, and you would see, well, 8 plus 6 is 14. All right, so hopefully that's pretty self-explanatory, pretty straightforward here. But for the no calculator portion of the test, you're definitely going to want to know these. And, you know, I'll also say that, you know, there's absolutely no shame in using your hands, using fingers, whatever it takes to get the right answer on the test. And, you know, so I just want to put this up here. So I think I'm going to start a new segment in my YouTube videos that I call the Champions Challenge. And the Champions Challenge is going to be a little part where I give a problem that I expect that most people are probably going to skip over it. And there's no shame in that. It's totally up to you to decide what is worth your time and what's not. And it's perfectly okay if you want to say, hey, I don't have time for this right now, or if you think you already remember these. Up to you to make that decision. There's no shame either way. But this is a little Champions Challenge right here, and that would be to pause the video and try to fill out this entire chart here. Maybe pull out a sheet of paper, take your time with it, and then once you're done filling out the chart here, you can compare your answer to what I just showed on the screen. So you would simply pause the video, pull out a sheet of paper, try to fill this out, and then just rewind the video to where I showed the table on the screen and compare your work to that. And I think that's going to be helpful for those who want to really test themselves and see how their addition is. But like I said, you know, I understand that everyone's got a different time pressure that they're working under. So it's up to you to decide if this is going to be worth your time or not. But for those who choose to do this, I think that this is going to be a worthwhile exercise to help see where you're at with addition. So that addition table is, I think, really good to review the addition, but it doesn't work as well with the subtraction table simply because there's negative numbers all over the place. So here's a subtraction table that I put here for you to reference to, but you have to keep in mind you really kind of have to look at the numbers right here in this column, and you have to kind of start with these numbers here. So for example, what I mean would be you'd have to say, well, what is 1 minus 2? You'd start at 1 and then find the row with the 2, and you'd see that it's negative 1. However, it's not going to work really the other way around. So if you want to know what is 2 minus 1, now that's a really easy example, but just let's say you wanted to know what's 2 minus 1. If you start here and then you go down to the 1s, you're going to see negative 1, and that's not correct. So you have to, for example, let me show you one more example of what I mean here. Let's say you wanted to know what is 2 minus 5. Okay, you'd start in the 2s row, come over, or start in the 2s column, go over here till you find the 5s row. You'd see 2 minus 5 is negative 3, which is right. But if you wanted to go the other way and you wanted to say what's 5 minus 2, if you started up here with the 5s row and you went down and found the 2, it would be negative 3. And 5 minus 2 is positive 3, not negative 3. So like, you know, to use this table, you have to start with, always have to start with the numbers in this column right here. If you start with the number in the row, like it's just going to give you the wrong answer here. So for a lot of the cases here, so I don't think that this is really all that helpful. Like, for example, if I want to know what's 9 minus 10, and I start here, I find the 9, and I go down here to the 10s. 9 minus 10, it should be negative 1, not positive 1, all right? Whereas, at the other hand, if I started here, if I started with the 9s column, and I said, hey, what is 9 minus 10? And I started here and I went over to the tens. I'd see, well, 9 minus 10 is -1. So you have to always start with the numbers over here for the subtraction table to be useful for you. And hey, if this subtraction table is kind of confusing for you, don't stress out about it. So you might have guessed this was coming up, but here's your Champions Challenge. And let me just give you one more example of how you do this if you want to take the Champions Challenge and fill out this table here. So you want to start going like this. So you want to start, what is 1 minus 0? The answer is 1. I put it here. What's 1 minus 1? The answer is 0. I put it here. What's 1 minus 2? Well, 1 minus 2 is -1. I put it here. What's 1 minus 3? Well, 1 minus 3 is -2. I put that here. So you have to start with the numbers over here in this column, all right? What will give you the wrong answer is if you start like this. If you go, okay, 0 minus 0 is 0, well, that one will be correct. But then you go 1 minus 0 is 1. Okay, 2 minus 0 is 2. 3 minus 0 is 3. Okay, it's not going to match. If you do it that way, it's not going to match the work that I just showed you on a couple minutes ago. All right, so if you want to complete the table, just remember, start like I just showed you here. Start with the numbers over here first and subtract everything up here, and you'll be good. So if you want to take the Champions Challenge, you can pause the video. You try to fill this table in, get out a pen and paper, however you want to do it, and then just simply rewind the video to where I first showed the table. And you'll be able to check your work to that. And I think it's going to be helpful for you if you want to do this. But like I said, it's totally up to you, to decide what is worth your time and what's not. Totally up to you. There's no shame either way. Okay, so next is our times tables here. And I would say that addition and subtraction are important to memorize those, but you can always kind of get away with using your hand for those or just counting on your fingers if you have to. But for the multiplication, this is, there's some patterns here that we're going to go over here, but there are some things that, I would kind of recommend memorizing these. Now, I'm sure a lot of these you probably do remember, I'm sure you probably memorized these second, third grade, whenever. I know I did, but I'm sure that you remember a lot of these off the top of your head as it is, but, there's always those random ones that you might have forgotten if you don't use them. Like for me, for example, if you just ask me some random thing like what is 8 times 6 or, what is 4 times 7 or just some random multiplication table that I never use in my daily life, I'd probably have to think for a second for some of these. I mean, some of them like 5 times 5, I'd right off the top of my head rattle that off. It's 25. But, for some of these other more like ones that I'd rarely have to use, I would have to probably stop and think. So there's no shame in having to take some time and refresh yourself on any of these. And, this is important for the no calculators section for sure. You don't want to spend, entire days just memorizing these, right? But I mean, it's worth spending a little time just making sure that you remember most of these. And so the best way to do that is to quiz yourself. And so let me show you how to do that. And I'll show you some patterns too. So by the way, I just took my microphone. It was in my shirt. I just put it down here on the table. So if you notice like a major change in the audio, let me know down below if you hate my mic being on my desk in front of me like this. Hopefully there's not a big change in the sound quality here. I am trying to get a better mic at some point. But anyway, here is the table. And let me show you some patterns though before I give you a chance to try this if you'd like to. So, it doesn't really matter which way you go. Like for example, 5 times 2 is exactly the same as 2 times 5. So, whether you think of this like, for example, 1 times 2 or 2 times 1, it's going to be the same answer either way here, which is different from subtraction where you have to deal with negatives and stuff like that. But basically, let's go over some patterns here. So I'll help you fill some of the table in. So 0 times anything is always going to be 0, right? So, if you go 1 times 0, it's 0. 2 times 0 is just going to be 0, okay? So you could really fill this whole thing in with zeros. And you could go this way too, right? You could go, what is 1 times 0? That's 0. What is 2 times 0? That is 0. All right, and you could fill this whole thing out with zeros too. So hopefully you'll remember whether you do 2 times 0 or if you go the other way around and you do 0 times 2, either way, it's always going to be 0, whatever number this is here. All right. Now, for ones, generally speaking, with the exception of 0, 1 times any number is going to be that same number. All right, so 1 times 1 is just 1. Okay, so if we go 1 times 2, that's just going to be 2. If we do 1 times 3, that's going to be 3. 1 times 4 is going to be 4. And you can go the other way around too. You could go 1 times 2. 1 times 2 is just going to be 2. 1 times 3 is just going to give you 3. All right, 1 times 4 is just going to give you 4. All right, so 1 times any number with the exception of 0 is just going to be that same number. Okay. So for 2's, really the pattern is kind of, you just have to understand that 2 times any number is like adding that number to itself. So what I mean by that is, let's do 2 times 7. Let's say for whatever reason, you draw a blank on 2 times 7. You would have to remember that 2 times any number is just like adding that number to itself. So 2 times 7 is the same as 7 plus 7. 7 plus 7 is 14. Therefore, 2 times 7 is 14. Okay, so any number, doesn't matter if it's, you can go the other way too. You could do 5 times 2, which I have over here. All right, 5 times 2 is the same as 5 plus itself. So 5 plus 5, 5 times 2 is going to be 10, just like 5 plus 5 is 10. Okay, so that's can hopefully help you with the 2's. Now, 3's and 4's, you're kind of on your own to memorize those or remember them. I don't really have any good tricks for those. 5's, I don't have a super good trick for that, but the way to kind of remember, or at least kind of check yourself, is that 5 times any number, or any number times 5, is going to always end in a 0 or a 5. So, for example, let's say I want to do, what is 5? All right, so let me fill this in. That's going to be 0. This will just be 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. And what I want you to see here is that, and I'm not going to keep going for the sake of time, and also because I want to leave some for you to try, but basically for the 5's, note that everything here is going to end in either a 5 or a 0. And if I filled this whole row in, and then, or if I filled this entire row in, and then I went up here and did this column down here, all of the numbers would end in either a 0 or a 5. So, if for some reason you try to, and I'm just picking examples here, I'm sure you remember that. You probably remember this off the top of your head. But let's say that, you had to do 5 times 7 and you're like, well, I think it's 34. You would know that it can't be 34 because it has to end in a 5 or a 0. So that's just one little trick for the 5's. Now, for 6's, 7's, and 8's, you're kind of just going to have to remember those. I can't really think of any good tricks for those. For the 9's, there's another way once you get past the 0's and the 1's, right? So, for example, 9 times 0 is just 0. 9 times 1 is just 9. Now, 9 times 2 is 18. 9 times 3 is 27. And so the pattern with the 9's is that both of the numbers, once you get into the double digits here, they're going to add up to be 9. So for example, with 18 here, 1 plus 8 is 9. Okay, with 27, 2 plus 7 is going to be 9. All right, so you can always check yourself if you've got the right value, because for a 9, it's got to add up to be 9. All right, so for example, let's say that, and I'm just picking an example here. I'm sure that this is something that you probably already remember this, and if you don't, hey, there's no shame in that. But let's say, I gave you a question like 9 times 3, and you just drew a blank, and you're like, I can't remember, but I think it's 21. Well, then you would have to say, I think it's 21, but you know what? 2 plus 1 does not equal 9, so that can't be right. I better try something else. So just kind of a little trick there. And then the 10's are pretty easy. You just add a 0 to everything, right? So you get 10 times 0 is just 0. 10 times 1 is just 10. So then here's what I mean. 10 times 2, you just take 2, put a 0 on it, would be 20. And you can go the other way too. Let me go the other way. So let's say you do, 10 times 3. Or let's say you do 3 times 10. 3 times 10 would be 30. I mean, I don't really care if you look at this as 10 times 3 or as 3 times 10. However you want to look at it, it's the same thing, same answer. But you basically, like this would be 40. All right, this would be 50, and so on and so forth. You're just putting a 0 on everything, even whether it's 12 times 10 or 12 times 10 times 12, however you want to look at it, it's 120. All right, so that's hopefully pretty easy. And then for 11s, okay, all you really do, there's a trick. It's going to be 2 of the same number for the most part. All right, so for example, 11 times 2 is just 2 2's, or 2 times 11, however you want to look at it. Like this would be 33, okay, and so on and so forth here. All right, and so basically like down here too, you could go the other way. Whether you look at it as 11 times 2 or 2 times 11, it's the same answer with multiplication. All right, 2 minus 11 and 11 minus 2 are two very different answers though. Okay, and with addition, 2 plus 11 and 11 plus 2 are going to be the same answer, right? But keep in mind that's not the case with subtraction. Okay, and then it gets a little bit different once we get down here. We would see 11 times 11 is 121, and then 11 times 12 is 132. So we don't really see the same pattern down here. So these are just two that you probably want to memorize because there's not really a good trick for those, but hopefully you're seeing here that 11s and 10s are pretty easy to memorize. The 12s you just kind of have to memorize, but to be honest, if you don't remember the 12 times tables, as long as you know how to do multiplication by hand, which we'll look at in a minute, like if you had to do like, I don't know, 12 times 3, and like you couldn't remember that, you could just do it by hand. Like you would say, well, 3 times 2 is 6, and 3 times 1 is just 3. And that's 36. So if you know this kind of process right here for doing these by hand, you don't necessarily have to remember the 12s, but, it's only going to save time if you just know right off the top of your head that 12 times 3 is 36. But again, you've got a lot of stuff to cover on the test. So, as long as you know how to do things by hand, like I just showed you right here, then, you probably don't have to take the time to actually memorize the 12s. You can do this whole table off the top of your head, then hey, you're in fantastic shape, So if you're feeling a little overwhelmed with all the multiplication tables and addition and stuff like that, don't worry so much because division is really fairly straightforward if you remember the multiplication times tables. Because if you know the multiplication tables, you can just kind of think through the division stuff without really memorizing them. So let me give you an example of what I mean here. So I'm just making this example up off the top of my head. Let's say I give you a division question. I said, what is 20 times 5? Or I'm sorry, 20 divided by 5. Now, if you don't know this off the top of your head, what you could do is just simply think about your 5 times tables. Think about it. What's 5 times 2? That's 10, which isn't what we want. What about 5 times 3? Well, 5 times 3 is 15. Well, what's next? 5 times 4. 5 times 4 equals 20. And that's perfect because since 5 times 4 equals 20, then we know that 20 divided by 5 gives us 4. All right, so see what I'm kind of emphasizing here is, knowing the multiplication times tables and understanding how to use them to reason your way through division. And, so you don't have so much stuff to memorize. So what if I were to give you something like this? What is 30 divided by 5, for example? So, with a way to think about this would be to think about what is 5 times what is going to give me 30. All right, well, if you think through your 5 times tables, 5 times 5 is 25, 5 times 7 is 35, 5 times 6 is 30. So the answer here is 6. Okay. So, I don't want you to get overwhelmed with the division. Just know the multiplication stuff the best that you can and, just kind of think through it like the way I'm showing you here in these examples. And so let me give you a couple insights here because, it's a lot of stuff here and I don't want you to, there's a lot to know on the GED and I don't want you to get too hung up on trying to remember all this stuff. But one thing you could do here is flashcards, for sure. And you can make your own flashcards, obviously, by hand if you want, but that can take a while. So you could also just simply Google addition flashcards, or you could simply Google multiplication times tables flashcards, something like that. Doesn't have to be Google. I don't know, whatever you're using. If you like Bing, or I don't know what else is there. Dogpile. People still use that. I don't know. Whatever search engine you like, just type it in. Division flashcards, division tables flashcards, something like that, and you'll probably find some. You can also use Quizlet. Quizlet is a free tool online where you can make. At least I'm pretty sure it's free. I haven't used it in a while, but it used to be. And you can make your own flashcards, right? So you could just make your own flashcards or Google. I'm sure you could find some. And really, one insight I would give you, though, is to focus on what you don't know. All right, that's why I think that it's a good exercise to, watch the multiplication, look at the multiplication table I showed you where it was all blank and pause the video and try to fill that in. Because I'm guessing that, let's say that maybe you remember all of them except there's 2 or 3 that you just draw a blank on because you haven't seen it in a while. Just as an example, what are you going to make flashcards for? You don't have to make flashcards for everything. You would just want to make flashcards for the 2 or 3 that you couldn't remember. Drill down on those, and that's going to save you a lot of time. Because if you try to make flashcards for every single multiplication times table, you can do that, of course. And but if there's a lot of them that you already remember, you don't have to keep going over those over and over again. I would find the ones that you can't remember, and focus on those. Make flashcards on the ones you can't remember. Go over those a couple times, maybe, for a couple days, and then, until it starts to stick for you. And one last tip I have is games. I don't have any specifically that I can remember, but, try to have fun with it. You could just Google multiplication times tables games. I'm sure just put it into Google, Bing, Dogpile, whatever search engine you're using. I'm sure you can find some free games to play. Just have fun with it. There's no shame in that. Probably do songs too. That's another one. I don't know. I'm just guessing. I could be wrong on this, but I'm guessing if you typed in multiplication table songs or something onto YouTube, probably find something there. Just have fun with it. Don't try not to stress out about it too much, because really there's only a handful of questions that you have to do without using the calculator. And so, is it worth putting some time into making sure you remember the multiplication times tables? Absolutely. But is it worth spending hours and hours and hours on? No, I don't think it is, in my opinion. So, it's up to you to make that decision. But let's move forward with some examples, and hopefully you'll see why I'm spending a lot of time on making sure we have a foundation for the times tables and addition tables. Okay, so let's say that I were to give you an example like this, 326 plus 259. And is this something that you remember how to do? And again, don't worry if it's not. If you don't remember how to do something like this, it's perfectly okay. That's what you're here to learn. But I'd just like you to pause the video, just try this out, see if you know how to do this. And hey, if this is easy for you, then you're in great shape. And if not, then hopefully you're going to learn something right now. So the way I would do this, just simply look at it this way. What is 6 plus 9? 6 plus 9 is 15. So I put the 5 down here. Then what I'm going to do is I'm going to put the 1 up here. Now I do 1 plus 2, which is 3. Then 3 plus 5, which is 8. And then I do 3 plus 2 is 5. So the answer to this would be 585. And so if you had trouble with this, or you didn't remember how to do this, definitely you'll want to seek out additional resources. I'm not going to show a ton of examples of this in this video for the sake of time, but I just kind of want to just help you figure out where you're at, what you know and what you don't know. So for example, if this is something that you didn't know how to do or couldn't remember, I would, use your textbooks or use your, workbooks if you have any, look at other resources, whether you just Google something or whether you could just make things up too, like just pick some random number like this and check it in your calculator. Like I'm just making this up off the top of my head, 287 plus 72, who the heck cares? Just make up some random numbers like this and try to add them, and try to add them by hand, and just use your calculator or use your phone calculator, or you can just type into your search engine bar, what is the answer to this, however you want to do it. But just if you had trouble with this, what I'm trying to say is, just get some extra practice. Be honest with yourself about it. We don't care right now. We're only practicing. I mean, in NBA players, they're not going to make every single shot in practice, right? They're not going to make every shot in the game. All right, but right now we're just practicing. Who cares if we get this right? I'm just trying to show you some different things to help you figure out what your weak areas are, and then I'm expecting that you will make some additional time whenever you're done with this video to try to fill in the gaps on some of those weaker areas. Okay, so next, without a calculator, I'd like you to pause the video, try to figure this one out, and we're just trying to see where you're at right now. So there's no shame one or the other whether you get it right. That's fantastic, but if you get it wrong, who cares? We're just practicing right now. So let's have you pause the video, try this, and then when you're ready, we'll go over it. Okay, so basically, what you have to see here is that you want to start by doing 2 minus 5, but the problem is that 5 is a bigger number than 2, so you can't do this directly. You're going to have to go to the 3, and you're going to have to borrow 1. So I'm going to cross this 3 out, and I am going to turn it into a 2. And I'm going to come back to this 2, and I'm going to stick a 1 in front of it and make it a 12. So we now have 12 minus 5. And what is 12 minus 5? Well, 12 minus 5 is 7. What about 2 minus 1? 2 minus 1 is just simply 1. So the answer to this is 17. All right, if you got that, fantastic job. And if you had trouble with this, one thing you can do is just make up something, just pick some random number like 21 minus, who cares, I don't know, 85, and well, this will actually give you a negative number, so that's probably not the best example. 21 minus 15, just pick random examples like this, random numbers, make them up, have fun with it, and just put it in your calculator to get the right answer. And just try to work these out by hand. That's one way you could do it. You could also just get in your workbooks and practice more. But again, I'm just, Sorry for going off on so many rants and tangents here, but I think it is really important to really understand why we're doing this. You know, we want to figure out what you know and what you don't know. And what you don't know is perfectly okay for right now, but I'm just trying to draw your attention to areas that you need to improve on. And when you find those areas, I'm expecting that you'll take some time and work on those and bring them up, and that's really going to help your score and help you get a foundation for harder examples. Okay, so next we're going to look at multiplication. So this looks like an X, but let's just pretend it's a multiplication symbol. So we've got 17 times 23 here. Again, 17 times 23. So let's have you pause the video and see how this one goes. Okay, thank you for taking the time to be here with me right now in this video. I know it's tedious. You'd probably rather be doing something else, so I appreciate you sticking with me. And to start this, you would do 7 times 3, which is 21. So see how it's important to know those multiplication times tables, because if you couldn't remember what 7 times 3 is, how are you going to get the right answer here? You have to maybe guess. If they give you multiple choice answers for this, which here I haven't given you any. But anyway, 7 times 3 is 21. So I drop the 1 right here, put the 2 up here. And so now what I'm going to do is I do 3 times 1, which is 3, but I add the 2 there. So I would make that a 5. So now what I have to do is I have to put a 0 down here. So let me cross this 2 out. And now we're going to look at the 2 here. So what is 2 times 7? 2 times 7 is 14. So I put a 4 down here. Now I'm going to stick a 1 up here. The 1 from the 14 goes up here. So 2 times 1 is simply 2. Plus another 1 is going to be 3. Okay, so now I have to do an addition here. All right, and I'm going to kind of run out of room here. So let me see if I can bring this. See if I can bring this all up. There we go. So 1 plus 0 is 1. 5 plus 4 is 9. And we just drop the 3 down. The answer here is 391. And so if you got this right, fantastic. If you struggled with this or didn't know how to do this, then hey, don't worry about it. Just either rewatch how I work through this. And if you still don't understand it, it's something that you want to make some time in the future to do some more, whether you look at other YouTube videos on this topic, on my channel or other places, or if you want to get in your workbook, if you have a workbook, not everyone does, and that's okay if you don't, or if you just want to Google some more examples of multiplication, just pick random numbers, try them by hand and check them in your calculator, however you want to do it, but, if you had trouble with this, hey, at least you know where you stand. Okay, so 77 divided by 3 is your next example here. So let's have you pause the video, give this a try, and if you just have no idea how to do it, don't worry about it. That's what you're going to learn. So now would be a good time to pause the video if you'd like to. When you're ready, we'll go over how to do this. Okay, so the way to think about this is to first, let's look at the first 7 here. And I'd like you to think 3 times what is going to get me a number that's close to 7, but it can't be bigger than 7. 3 times 3 is going to give me 9, which is bigger than 7, so that won't work. But 3 times 2 gets me 6. So I'm going to put a 2 up here because 3 times 2 is going to give me 6. And I'm going to bring my 6 right down here. Okay, and the next step is I'm going to subtract them. What is 7 minus 6? Well, the last time I checked, 7 minus 6 is 1, so that's what we're going to roll with. So we put the 1 down here. Now I'm going to simply bring this 7 down. So I just dropped the 7 right down here. So now I have to think 3 times what is going to get me something that is close to 17, but it can't be bigger than 17. So let me think about this here. Well, 3 times 6 is 18. That's not going to work because that is bigger than 17. But 3 times 5 is going to give me 15, which is perfect. So we throw our 5 down here. And I'm going to put my 15 down here because, again, 3 times 5 is 15. So now I subtract 17 minus 15, and it's 2. And so the answer is 25, remainder 2. All right, so this is an example of division, and, it doesn't get too much more complicated than this. I do have a video on division. If I remember, I'll put a link to it in the description. I oftentimes don't remember, so if you want to, you can either just go on my channel page and type in, or just go on YouTube, just go up in the search bar and type in Test Prep Champions Division. I have that division video, 15 to 20 minutes. You'll probably know how to do questions like this. Okay, so now let's talk about how to deal with negative numbers. And so there's a couple basic rules for multiplication and division. And let me first give you a chance to try this. I have negative 27 times 4 on the screen here. So let's have you try this one out, and then we'll go over how to do it. Okay, so basically, what you would do to get this right is you have to do, first, for multiplication, I wouldn't even worry about the negative initially. Let's just go through this how you normally would. So 4 times 7 is 28, so you put an 8 down here, and we put the 2 up here. Now, what is 4 times 2? 4 times 2 is 8. You have to add the other 2, so that's going to bump us up to 100. So we have 108. And now, since we have a negative number times a positive number, the answer is going to be negative, all right? If this had been a negative 4, if this was negative 4, all we would do is we do it the exact same way. We'd have 108 as our answer. And since it's a negative times a negative, it would just be positive 108. So the only time you can get a negative number in multiplication is if you do a negative number times a positive number. All right, so remember this. A negative number times another negative number is always going to give you a positive number. Now with division, it's the exact same thing. If you divide two negative numbers, you're going to get a positive number, right? So if you do, let's just do something really simple here just to show this. Let's say I want to do negative 8 divided by negative 2. All right, the answer is simply going to be, if I do negative 8 divided by negative 2, positive 4. All right, a negative divided by a negative gets you a positive. Now, if this was a negative divided by a positive, like negative 8 divided by positive 2, the answer would now be negative 4. All right, so for division, a negative divided by another negative gets you a positive. A negative divided by a positive gets you a negative number. So the same exact process for multiplication and division, you just do them how you normally would, and you just have to think, if it's negative times positive or negative divided by positive, the answer is going to be negative. If it's negative times negative or negative divided by negative, the answer is going to be positive. So that's hopefully pretty simple for division and multiplication. So now let's talk about how to deal with addition and subtraction here. And we're also going to kill two birds with one stone, because we're also going to talk about number lines, which you also have to know something about for your test. So we have negative 5 plus 3 here. And this is also the same. You could rewrite this as 3 minus 5. It's two ways of writing the same exact thing here. But I want to look at it as negative 5 plus 3 right now to show you how you would use a number line to solve something like this. So actually, you know what? Let me give you a chance. Let's have you pause the video, try to solve this, and then we'll go over it. Okay, so maybe this was really simple for you. Maybe it wasn't so simple. But I don't really care. I don't care if you get every single question in this video wrong, as long as you learn something. So basically, here's my little stick figure drawing, and I'm going to start the stick figure at negative 5 here, okay? And since it says plus 3, that means I want to go to the right 3 places. So let's say I jump here, and then I take another leap here. That's 2 leaps. Then I take a third leap here. And my stick figure person is going to end up at negative 2. So the answer to this, if we use the number line, is negative 2. All right, so now let's think about it this way. Let's do it. Let's say we've got negative 1 minus 3. All right, so I'd like you to pause the video, try to figure this out, and try to think about it with the number line. If you already know the answer to this off the top of your head, just try to look at the number line and just think, how would you do this with the number line? I know for some people out there watching this numbers are going to be quite simple. For other people, this might be challenging. I know we're all at different levels here. So let's have you pause the video, regardless of where you're at. Try to think about this, and we'll go over it. Okay, so now we've got negative 1 minus 3. So here's how I want you to think about it. So start with, now you can't draw a stick figure on your test, so you can just do it in your head. But basically, on this number line here, we want to start at negative 3. And since it says we want to start at negative 1. And since it says minus 3, now we're going to go to the left 3. So let's say the stick figure goes 1, goes 2, goes 3, and the stick figure is going to land on negative 4. So that is simply, the answer would simply be negative 4. Okay, so when you do a question like this, basically, here's another little trick to remember this. If you've got negative 1 minus 3, you could just think of it like 1 plus 3, which is 4, and then put a negative in front of it. So for example, if you had negative 5 minus 2, one way to think about this would be, well, how would I do 5 plus 2? 5 plus 2 is 7. then just remember to put the negative there. So that's another kind of pattern if that makes it faster for you. But it's always helpful if you get something tricky, just think about a number line. Just think about the number line because it helps, and you might have to use the number line for certain questions on your test. So now that we have our number line up on the screen, a good transition would be to talk about absolute value. So what is absolute value? Absolute value is the distance from 0. All right, so it is the distance from 0. And so if you're taking notes, that would be a good thing to write down. That absolute value is the distance from 0. So what do I mean by that? Well, the other thing you should know about absolute value is that you're going to see bars like this. And you can think of them as bars or brackets, however you want to put it. But when you see a number that is in between these bars, that's what we call an absolute value question. Now, absolute value shows the distance from 0. So if I find -5 down here on my number line, let me show you what I mean by the distance from 0. So if this is 0 right here, so here's 0, and here's -5, well, how many steps are there between -5 and 0? So if I walk towards 0, I would say 1, 2, 3, 4, 5. So between -5 and 0, there are 5 steps if we think through the paradigm of our stick figure here. And so the distance, the absolute value of -5, in other words, the distance from 0 of -5 is simply 5. Now we could think of it the same way as, if we did absolute value of -2. It's exactly the same. Absolute value of -2. In other words, what is the distance between -2 and 0? Well, here's -2. Here is 0. And if our stick figure was going to walk from -2 to 0, they would go 1, 2 steps. Absolute value of -2 is just simply 2. So the other thing you should know about absolute value, if you haven't seen it by now, is that it's always going to be positive. So it doesn't matter what it is. I could put any random number in here, and if this is my number here and I put it in, I want to know what's the absolute value of this number, it's just going to be that same number, but it's going to be something positive. So the absolute value is the distance from 0, and it's always going to be positive. Now the other thing to know about absolute value is that in your when you do operations or calculations with absolute value in them, you want to treat it like it's a parentheses. And so if you're not sure what I'm talking about, this is something I've talked about in a lot of other videos, but let me just give you a really brief rundown here. And this is something that is really, honestly, one of the most important things to know for your entire test, and I'm not going to teach a whole lesson on it here. But, the order of operations rules, or PEMDAs, some people remember this as please excuse my dear Aunt Sally. However you want to remember it. But basically, this just kind of gives you the rules to follow when you are doing a calculation that has multiple things in it. So let's say I gave you something like this, like 3 times 2 plus 1 plus 2 minus 1, just something like this. I just made this up off the top of my head. How would you know where to start? Would you try to do, 2 plus 1? Would you start with 2 minus 1? Would you start with 3? How would you know how to start this? And if you haven't studied this yet for the GED, or if you don't remember this from high school, know that, if you get the order of operations rules wrong, you're going to have a lot of trouble with the GED, whether that's the no calculator or the calculator portion of the test. So, like I said, I don't want to do a whole in-depth lesson on this now, but basically the order, the P stands for parentheses, the E stands for exponents and square roots, the M stands for multiplication, the D stands for division, the A stands for addition, the S stands for subtraction. So basically, where I would start would be, I would start with the P, what's in the parentheses. So if I were going to solve this, I would do 2 minus 1 first, and then I could take my P out. Now, we don't have any exponents or square roots, so now it would come down to, do I want to do the addition or the multiplication next? Well, M comes before addition in my order of operations rule, so I would do the multiplication next, and then I would finish with the addition. So I'm not going to actually solve this question out. I'm just showing you, remember, there's 3 points to know about absolute value. 1, absolute value is the distance from 0. 2, absolute value is always positive. And 3, in the order of operations rules, you always want to treat the absolute value as just like you would parentheses. So in other words, that's going to be one of the first things that you always want to address. So let me give you an example here. Let's say I gave you 4 times the absolute value of 10 minus 20. How would you solve this if I said, tell me the answer of 4 times absolute value of 10 minus 20? So pause the video, try to figure this out, and then when you're ready, we'll go over it. Okay, so the way you would do this is you have to start with what is inside of our brackets here. All right, and what's inside the brackets here, it's 10 minus 20. So let me rewrite this. Now, what is 10 minus 20? 10 minus 20, I'm pretty sure, is negative 10. All right, but whatever is inside the absolute value, remember the absolute value is always positive. So rather than doing 4 times negative 10, I'm really doing 4 times 10, and the answer to that is just 40. So hopefully you got 40, and if not, hey, don't worry about it. Like I said, I don't care if you get every question wrong as long as you're learning something here. This is a good example. I like this because it's simple, but it really addresses the main points you need to know about absolute value. Number 1 is that distance from 0 is what the absolute value is. But number 2, you always need to remember that whatever's in the absolute value, whether it has a negative sign in front of it or not, the answer is still going to be, the absolute value is still going to be something positive. So, you wouldn't do 4 times 10, you would do 4 times negative 10. Okay, and so now you also would have to know that, when you have a question like this, 4 times the absolute value of 10 minus 20, you would have to start with what is inside of the brackets. Okay, so let me give you one more example here, and this is going to be something a little bit different here. And so now I'm going to make this negative 4 times the absolute value of 10 minus 11. So let's have you pause the video. As always, let's have you try this out, and then we're going to go over it. And just by trying these out, whether you get it right or wrong, it's going to hopefully help this stick better for you on the test. Okay, so as always, we need to start with what's inside the parentheses, all right? And in this case, we have 10 minus 11. So 10 minus 11 is what? 10 minus 11 is going to be negative 1. But since it's inside the absolute value, it's really, you treat it like positive 1. So it's negative 4 times 1. And the answer is going to be negative 4. All right, and so remember, in this case here, the negative 1 that's inside of the parentheses, that's going to become positive 1. All right, it's going to be treated as positive 1, is what I'm trying to say here, because the absolute value is always positive. But we have this negative 4, so it's negative 4 times the absolute value of negative 1. This negative 1, you would treat that like positive 1, because the absolute value is always positive. But we still have that negative sign in front of 4. So we still have the negative 4, so the overall answer is just simply negative 4. So I know I'm throwing a lot at you right now, so just keep in mind that I do have a video on order of operations rules and a video on absolute value. I'll try to remember to put links down below if I forget, which I probably will forget because I usually do. Just remind me in the comments below, or you can just go on my channel or search for them. But I have videos where I break this down, and of course, you could also check textbooks, check other places, whatever you want to do. But the please excuse my dear Aunt Sally rules are important to know. Absolute value can come up on your test as well, so they're both important to know. Okay, so next we're going to talk about decimal operations, meaning addition, subtraction, multiplication, and division with decimals. So here's an example for you to try if you'd like to, and I'll let you pause the video, try this out. Okay, hopefully if you wanted to, you got a chance to try this out. So what I always recommend for people to do is to, whenever you get a question written like this, just rewrite it, stack them up on top of each other. Now, you're of course free to decide if you want to do that on your test or not. But I think it's easier to visualize decimal operation questions if you just line them up, one on top of the other. But, hey, it's up to you to decide that when you go in there to take your test. So for addition and subtraction with decimals, it's really the exact same thing as if there wasn't a decimal here. You just drop that decimal straight down here. So what is 2 plus 6? 2 plus 6 is 8. What is 3 plus 5? 3 plus 5 is 8. And, well, imagine there's a 0 here. 5 plus 0 is just 5, so we pull the 5 down. The answer is 58.8, and you can see how, the decimals are all in line right here. So that's the key with addition and subtraction with fractions. You just simply have to just line up the decimals and just do it like you would a normal question without a decimal. So a little bit different with multiplication and division. Okay, so next let's talk about multiplication with decimals. And so basically the same rules for multiplication with decimals are also true for division. And the example here is 3.5 times 0.12. So if you'd like to, now would be a good time to pause the video, try this one out, and I don't care if you get it right or if you get it wrong. We're all about the learning, we're all about the process and getting better. So either way, if you want to try it, now's a good time to do so. Okay, hopefully you had a chance to pause the video and try this if you wanted to. So division and multiplication with decimals, it's a different process than addition and subtraction. So the way I would do it is I would take the two numbers here and stack them one on top of the other. Okay? Stack them right up on top of each other here. And that's I think it's when you're not using a calculator, it's way easier to see if you do it this way. I mean, if you can do it without a calculator without rewriting it, hey, that's probably going to save you a little bit of time, but this is how I think it's just easier this way. Just my opinion. But you want to approach this just like you would a normal multiplication question without the decimals, and I'll show you how to deal with the decimals at the end. So 2 times 5 is 10, so I put the 0 here, pull the 1 up. 2 times 3 is 6, and I add that 1, making it 70. So I want to drop my 0 down here, and I want to do 1 times 5, which is simply 5, and 1 times 3, which is just simply 3. All right, so now what I want to do is I want to add these up here. Okay, and what is 0 plus 0? 0 plus 0 is 0. 5 plus 7 is 12, so I put the 2 here, put the 1 up here, and 3 plus 1 is 4. So I have 420 right here. But now I have to go and consider my decimals. So for multiplication and division, what you have to do is you have to look and see how many numbers are there to the right of the decimal point. All right, so 3.5, I've got one number to the right of the decimal point. If I look at 0.12, I've got two numbers to the right of the decimal point. So now what I want to do is I want to go down here to 420, put a decimal right to the right of it to start. And since I have three places to the right of the decimal up here in the original question, I got to take this decimal and I've got to count 1, 2, 3. And I would rewrite this as 0.420. Now you really don't even need to write this 0 here, so you could just write it as 0.42. But the point is, for multiplication and division, you just do the question like you normally would. So for this question here, you do 35 times 12 like you normally would. Then once you got the answer is 420, remember that's not the final answer. You just go back up here and count how many places there were to the right of the decimal points. And then you just go down here and take that into consideration in your answer. And that's how we got 0.420. Okay, here's a quick crash course on fractions. Now, there's three different types of fractions that you should know about for the GED test. There's what we call proper fractions, improper fractions, and mixed numbers. Now, a proper fraction is going to have a smaller number on top and a bigger number on the bottom. Now, I should mention that the top number of any fraction is called the numerator, and the bottom number is always called the denominator. And a lot of people like to remember the denominator is downstairs or in the dungeon. So if you forget which is the numerator or the denominator, you just think, okay, well, the denominator is in the downstairs or the dungeon of the fraction. Now, I have a little trick to remember that the top number is called the numerator, and it's really, really stupid. It's so stupid that I almost don't want to share it because it's so dumb. But basically, if you've ever had the salad dressing called Newman's salad dressing, maybe you don't know what I'm talking about, and that's perfectly okay. But, your salad dressing is going to go on top of the salad, right? So think about that. Newman's salad dressing is on top of the salad. The numerator is the top part of the fraction. So that's why I didn't even want to share that because it's so stupid. But, if that helps you remember that, then, great. But a proper fraction, the top number is smaller than the bottom number. In an improper fraction, on the other hand, an improper fraction is going to have a bigger number up top than on the bottom. So the numerator of an improper fraction is bigger than the denominator. Now, a mixed number has a whole number and a fraction to it. So we see here we've got 3 as our whole number, and we've also got a fraction to it. And you can actually go back and forth between improper fractions and mixed numbers. So let's look at this 3.5 for an example. So how would you take this 3.5 and convert it into an improper fraction? So if you think you know how to do that, you can pause the video and try to turn this mixed number into an improper fraction. And if you don't know how to do it, then don't worry, that's what we're going to learn. Okay, so if you wanted to try this out now, hopefully you had a chance to do so. If not, let me show you how to do it. So the trick to converting a mixed number to an improper fraction is that you have to understand that the denominator is going to be the same. So both the mixed number and an improper fraction will have the same denominator. So if I look at my next mixed number, I look at the fraction, I see that the denominator has a 2 in it. So if I want to convert this mixed number into an improper fraction, I know that my improper fraction will also have a 2 downstairs in my denominator. So how do I get the top number? Well, all I have to do is I do 2 times 3, and then I add the 1. So again, I do 2 times 3 plus 1. So 2 times 3 is 6, plus 1 would be 7. So if I wanted to convert this mixed number to an improper fraction, 3/2 is equal to 7 over 2. And if you don't believe that, or you just want to check for yourself, you can use your calculator. Now, half is equal to 0.5, so 3.5 is the same as 3.5. So if in my calculator I plug in 7 divided by 2, or 7 over 2, that will equal 3.5. All right, so that's just one way to check. Now, let's talk about this example right here, this improper fraction, 4 over 3. How could you convert this to a mixed number? So I'd like you to pause the video and give this a shot if you'd like to. Try to convert this 4 over 3 into a mixed number, and then we'll go over how to do it. Okay, so right off the bat, we know that our mixed number is going to have a whole number and a fraction. And we know that the denominator is going to be the same as the improper fraction. Let me try to pull this out of the way so that we've got some room to work here. There we go. So I know right off the bat when I'm converting 4/3 into an improper fraction when I'm converting 4/3 into a mixed number, I know that the denominator of the mixed number is going to be 3 because the denominator of the improper fraction is 3. So now what I have to do is I have to think about numbers that you can multiply 3 by that will get me a number close to 4, but it has to be less than 4. So if I pick 2, for example, 2 is not going to work because 3 times 2 is 6. 6 is greater than 4, so that's no good. But what about 1? Well, 3 times 1 is going to be 3, which is close to 4, but not quite 4. So that's what I'd want to do. And then I have to think about, well, 3 times 1 is 3. If I add 1 to that, it's going to get me 4. So I would put a 1 here. All right, so this is how I would convert 4/3 to a mixed number. And if you ever get a mixed number and you want to check if it's right, you can simply turn it back into the improper fraction. So remember how to do that. You would do 3. Remember, it's going to have the same denominator, so I'll put the 3 down here. Then I would do 3 times 1, which is 3, plus 1, which is 4. And so you can see right here a perfect example of a mixed number. You can convert it into an improper fraction and vice versa. All right, so I know I went over this kind of fast. I know it's a lot of information, but it is important to understand how to do an improper fraction conversion into mixed numbers and vice versa. If you just picked it up from this quick example I just showed, that's great. If not, I have, like always, I've got other videos on here that you can watch about how to do this on my channel. I'll try to put a link down below. Remind me in the comments if I don't put that link, or you can search on my channel. But this is a fundamental skill. Once you practice it a little bit, hopefully you'll be able to pick it up pretty quickly. Okay, let's talk about adding fractions now. So I had to write this out just because it's easier for me to write it out than try to type something like this out, at least the way I'm making the video. But basically, let me read this so you can understand my writing. I've got 3 over 5 plus 2 over 15. So I'd like you to pause the video, give this one a shot. How would you add fractions? And then we will go over it. So now's a good time to try it. Okay, hopefully you had a chance to try this if you'd like to. So the trick to adding fractions is that the numbers in the denominator have to match before I can add. And in other words, I have to find a common denominator. Now here I've got 3 over 5 plus 2 over 15. So what I want to do is I want to look at this 5, and I want to ask myself, how can I turn this into a 15? Well, 5 times 3 is equal to 15. And whatever I do to the denominator, I also have to do to the numerator. So I'm going to multiply by 3 up here as well. So let me rewrite our problem now. So up top here, I'm going to have 9. Why 9? Well, because 3 times 3 is 9. And down here, I'm going to have 15, because 3 times 5 is 15. All right, so now I add to 2 over 15. And now all I have to do is I would just do 9 plus 2, which is 11, and I just make it 11 over 15. All right, a common mistake here would be to think, well, I add 9 and 2 and get 11, then I take 15 and 15, well, that's 30, and the answer is 11 over 30. But that's not quite how we do this. The way you do it is you just leave the denominators the same. You just make this 15 here. All right, so you just bring that denominator along for the ride. So let me show you another example here. Let's do 3/4 plus 2/3. Okay, so how would you add 3/4 and 2/3? So I'd like you to pause the video and try your best. Just try to use the technique I just showed you. Try to figure it out. And as always, hey, if it doesn't work out for you, don't worry. We're just practicing. Don't care if you get it right or not. It's all about the knowledge right now. Okay, so we see that we're adding fractions here, and we see that we have to get a common denominator. So we've got 4 here, we've got 3 here. So what I'm going to do is I'm going to look at my 3 over 4, and I'm going to say, hey, well, the second fraction here has a 3 in the denominator, so I'm going to multiply both the top and the bottom numbers over here by 3. And now I'm going to go over to my other fraction, 2 over 3, and I'm going to say, hey, there's a 4 down here in the denominator, so what I do is I multiply both the bottom and the top numbers by 4. Okay, so now let me rewrite all of this. So we've got 3 times 3. What is 3 times 3? 3 times 3 is 9. What is 3 times 4? 3 times 4 is 12. And what is 2 times 4? 2 times 4 is 8. And 3 times 4 is 12. All right, and so now what we're going to do is we just do 9 plus 8, which is 17. And then 12 plus 12 is 24. All right, we're ready for the next question. Actually, no, we're not. So I put this 24 down here just to see if you were paying attention. Because remember, hopefully you remember that I said that you don't want to add the 2 down here. All right, so it's actually going to be 12. So I just did that. It's kind of a joke to see if you were paying attention. It's actually going to be 12 down here. So I'm willing to bet maybe somebody out there just went down in the comments and typed in, hey, it's not supposed to be 24, it's supposed to be 12. And then they didn't watch the next 10 seconds of the video where I explained that it is supposed to be 12. So, you know, maybe I'm wrong. Maybe no one will type that in the comments, but we'll just have to wait and see. But anyway, the answer here is 17 over 12. So let's do another Champions Challenge right now. So the Champions Challenge would be to take this 17 over 12 and convert this from an improper fraction, which it is, into a mixed number. So let's have you pause the video. What is 17 over 12 as a mixed number? Okay, so hopefully if you wanted to, you had a chance to pause the video and try that. So remember, when I'm going from an improper fraction to a mixed number, we are going to keep the denominator the same. So right off the bat, I can take this 12, I can write it down here in the denominator. Now, I want to think 12 times what is going to get me a number that's close to 17, but it has to be less than 17. Well, 12 times 2 is 24, so that's not going to work. That's too high. 12 times 1 is just going to give me 12. All right, so now I've got 12 times 1 is 12. Well, what can I add to 12 to get me 17? Well, to figure that out, I would just think, 12, 13, 14, 15, 16, 17. Well, hey, it's 5. And you don't really have to count on your fingers there, but there's no shame in that if you have to. Whatever it takes to get the right answer. Another way to think about this too would be here's a way some people like to do it. They will say 12 times 1 is 12, and then they'll come back here to the 17, and they'll do 17 minus 12, which of course equals 5. and then they'll just plug the 5 in here. So just another way to think about this. And like I said, I know I'm kind of throwing a lot of stuff at you right now, kind of fast, but I'm just kind of trying to throw a lot of stuff at you, and whatever sticks. And then, like I've said throughout the video, I'm just expecting that whatever you, after watching this, need work on, you'll go back and put some time in. We're just trying to figure out what you know and what you don't know to get you up to speed here to be able to tackle some harder questions so that you can get your score up and you can pass the GED and move ahead. So now we talked about addition with fractions, and so you should hopefully know that, or if you don't know, now I'm going to tell you, that subtraction with fractions is exactly the same thing. What we were just doing with addition, same process. So if I gave you a subtraction question, you just have to get the denominators to match. You have to get a common denominator, and then you just subtract. You keep the same denominator in your answer. It's exactly like addition, only it's subtraction, all right? But multiplication and division are quite a bit different. Actually, multiplication and division are way easier, I would say. Let me give you an example here. I've got 2/3 over 1/4, and I'm just making this up off the top of my head. And just so you can read my handwriting here, I have 2/3 times 1/4. And so I'd like you to pause the video and try to figure this out. How would you do this question? And then if you don't know how to do it, like always, don't worry about it. That's what we're going to learn. Okay, so for multiplication and for division, but let me talk about division separately. Let's stick with multiplication. So for multiplication with fractions, you do not have to get a common denominator. Don't try to get a common denominator. So two big mistakes with multiplying fractions is people get it confused with addition and subtraction, and they will try to get a common denominator. So if you try to do that, don't worry about it. Like I said, it's all about the process. It's all about the knowledge. Just know for your test that you don't do that with multiplication and division. And also, another mistake people make is they'll remember that they learned something before about, I don't know why this is set blend mode, it's kind of annoying, but they'll remember that they learned something before about cross multiplication, and so they'll think that you solve a question like this, you do 2 times 4 and 3 times 1, but that's actually incorrect. So for cross multiplication, the only time that you would cross multiply would be if you had like a situation like this, like if you had 2/3 equals 1/4, and I don't know, maybe you'd have, 1/4x or something like that. And in a case like this, you would absolutely cross multiply. You do 2 times 4x and 3 times 1. So you only cross multiply if there's an equal sign in between the fractions. For a situation like this, where the fractions are both on the left side of the equal sign, so here's the equal sign, you see that 2/3 times 1/4, all the numbers are on the left-hand side of the fraction. Don't try to cross multiply like that. It's not going to give you the right answer. So if you did that mistake, again, hey, don't worry about it. At least you're trying. Sometimes you have to make a mistake, and that's what's going to make it stick. Okay, so I just want to show you how to do it right so you can get a good score, and so life will be good once you pass the test. And so here's how you do this. So you just multiply right across. It's really simpler than trying to cross multiply. It's simpler than getting common denominators. You just do 2 times 1, which is 2, and 3 times 4, which is 12. And the answer is simply 2/12. Now, we could also simplify this fraction. Since we've got 2/12, we could divide both the top number and the bottom number by 2, and that would give you 1/6. Okay? But if you got to 2/12, I'm happy with that. I don't care if you did 1/6 or not, but technically you would want to get your answer in simplest form, which is another trick to know for your test. If you ever get a fraction and you look at the answer choices and your fraction doesn't match the answer choices, but you're pretty sure you did the math right, know that your answer is probably not in simplest form. And I do have a video on simplifying fractions, but if you want to see a bunch of tricks for that, you can check out that video. Usually, your calculator, if you plug them into your calculator, you plug a fraction in, it should put it in simplest form for you, at least as far as I know. That's what I read anyway about this calculator. Maybe somebody could verify that, but anyway, if you've had experience trying it, I can't speak for, I haven't done it myself. I've just read that this calculator, this is the kind you need for your test. You don't have to buy this, but if it'll give you an on-screen calculator, but if you want to buy it, it's the TI-30XS. Right now with the online testing and stuff, I've heard that you can't use a calculator for the online testing. So, I wouldn't worry about buying it if you're planning to test online, but anyway. Let's see here. We've got 3/4 times 7/5. So how would you do this multiplication question here? So let's have you pause the video, try this out, and then we'll go over it. Okay, so what you do here is 3 times 7 is 21, and 4 times 5 is 20. So it's really that simple. It really is. It's really that simple. There's not all that much to it. It's really all that simple. 21 over 20. Now here's a champion's challenge for you. We've got 21 over 20. That is an improper fraction. So how would you convert this improper fraction to a mixed number? So let's have you pause the video, try that out, and then we'll go over it. Okay, so remember, an improper fraction is going to have a bigger number in the numerator than the denominator. So basically, but the denominator is the same with the mixed number. All right, so I can write 20 right away as the denominator of my fraction. Now I have to think 20 times what is going to get me something close to 21. And 20 times 1 is just 20, which is very close to 21, so I have that. So 20 times 1 is just 20. And then plus 1 is going to give me 21, so I put the 1 up here. All right, so that's how you would do that if you wanted to convert this to a mixed number. If you got this, great job. If you tried it and didn't get it right, great job for trying. And now let's talk about division. So basically, and I know I'm using simple numbers here, but the process is exactly the same. I mean, you know, for the sake of time, I'm not going to give you something like really super nasty, like, I don't know, 4... something super insanely like just really big obnoxious numbers like this, because it's just, I don't think there's really much of a point. But if I were to give you something like this, and I don't think they're going to give you something this outrageous on the test, but you'd want to use a calculator obviously to do this. But you know, if I gave you 112 over 456 times 19 over 999, something really super obnoxious, the numbers would be exactly the same. You would just do the process would be exactly the same. You would just do 112 times 19. That would be on the top of your fraction. 456 times 999, that would go down here, and then you might have to simplify it. I'm not sure. I'm not sure what the answer would be to this, and I don't really care what the answer is. I'm just saying, you know, don't think just because we're using easy numbers like 3 over 4 and stuff like that, that, you know, the harder examples are any different, right? The only thing different about what the process I'm just showing you here, and, you know, you might get something more complicated on your test, but really more complicated is not the right word, right? You know, if I give you something simple like this 3 over 4, you know, or if I give you something like 23 over 44, you know, it's the same exact steps. It's just the number is a little bit bigger and a little bit stranger. So let's talk about division. So if I were to give you 4 over 9 divided by 10 over 11. So we now have 4 over 9 divided by 10 over 11. So how would you solve this? So let's have you pause the video, just give it a try. You never know what can happen, and then we'll go over it. Okay, so the way you do a division with fractions question is you have to take the second fraction and flip it upside down, and then you just treat it like a multiplication question. So if we do 4 over 9 times 11 over 10. Okay. So all we're going to do here, we've got 4 over 9 times 11 over 10. And we would do, what's 4 times 11? That's 44. What is 9 times 10? 9 times 10 is 90. And if you want to simplify it, what's 44 divided by 2? That is 22. What's 90 divided by 2? That would be 45. So you could get down to 22 over 45. I don't care if you simplified it as long as you got to this here. I would consider the right answer. But the more important thing, whether you got the answer right or not, is just to remember when you've got a division with fractions question like what we see here, you're just going to take the second number and flip the question upside down and it becomes multiplication. So let me give you one more quick example here, and the repetition is always good. And again, we're just using basic numbers, but I could put some really scary, like, huge, nasty number in here. And the process is exactly the same. It's exactly the same. It's just the numbers are way bigger. That's the only difference. And, you know, we're trying to cover the basics right now, so that's why we're using simple numbers. But, you know, whether I use harder numbers, the only difference is you're going to get a stranger answer probably, but it's the same exact technique. So let's have you try this. What is 4 over 9 divided by 3 over 2? Okay, hopefully you had a chance to pause the video if you'd like to. And so the process is really exactly the same. It's just 4 over 9. And you're going to take this 3 over 2 and flip it upside down and make it 2 over 3. All right, and then you're just going to multiply across. So 4 times 2 is 8, and 9 times 3 is 27. And so simply put, that is the correct answer. Now here's a little throwback to earlier in the video. If I did 9 times 3 off the top of my head, and I was like, is 9 times 3 really 27, if I were confused on that? The way I would check it is you just say, well, 2 plus 7 equals 9, so this must be one of the 9's times tables, all right? So just a little factoid there, a little throwback to earlier in the video, but basically we've got 8 over 27. That's our answer to this. Hopefully that makes sense. We've now covered addition, and by covering addition, we also covered subtraction, covered a couple examples of multiplication and division. Okay, so here's another question, and this is a really important question, and it says, which of the following decimals is equal to 2%? Is it A, 0.02, or B, 0.2, or this should say C, none of the above. So imagine that this is a C. And, this is really important because questions like this, these little basic math things sometimes can cost people points on the test if they don't remember how to do this. So let's have you pause the video, pick, is it A, B, or C, and then we'll go over this. Okay, so what you should know here is that 2% is equal to 0.02. So A would be the correct answer here. And if it was 20%, note that 20% would be equal to 0.2. Okay, so you should know this. It's important because if you get something like 6%, all right, you would have to know that 6% is going to be equal to 0.06. And if you got 60%, that would be equal to just 0.6, all right? Because there's a question on the GED Math Study Guide by the official testing service where, this was just the first step in the question, if I remember right, was to convert a percent to a decimal. And I think you had to do something else too, but if you didn't know how to do this right, you'd be dead in the water. So that's why I'm showing you this. And that study guide would be a great next step. If you like this video and thought this was helpful, that would be another good step would be to watch that next. So thank you so much for being here. Good luck on your test.